都有，我后来再修，反正我外他们都够了。OK， 好，那你就忙1点10点。
Let me ask one question first. How many international students can you understand Chinese? Okay, good. Okay. Now, because I'm thinking if you can understand 40% of Chinese and all the local Taiwanese can only understand 30% of English, then I had a better to conduct in Chinese. You know what I'm saying, right? And anyway, because some of the international students can understand Chinese at all. So throughout the whole semester, this course will be conducted in English. Okay, I may not summarize in Chinese. So especially for the Taiwanese students, don't wait for my Chinese. Okay. Okay. Well, actually, this is my last lecture in my whole academic career. So you will be my last student for the class. Okay. So anyway, even I'm going to retire soon, I will give you all the information is up to date, even up to January this year. Okay, but I may not have chance to talk about it because there are so many topics to cover. Okay, but anyway, the title is called Data Pattern Classification and Recognition because it is first offered almost 15 years ago. At that time, there's no buzzword about big data or even machine learning. Machine learning has existed in the community long time ago, but it's not that popular. So because we are in industrial engineering, so I prefer to call it data pattern because we need to handle all kinds of different data for engineering application. So that's the reason why I prefer. Well, actually, in 15 or even 20 years ago, this more popular word is called pattern recognition. Okay, it is even more popular compared to machine learning because everything can have a pattern, no matter what the data or your behavior, humans' behavior. Okay, economy, weather pattern, stock market, and anything has its pattern. Okay, so in the early days, we focus on the pattern recognition, and most of the algorithms developed by the image processing guy, because in image processing we need to focus on feature extraction and image analysis, and then the high-level classification, okay, or segmentation. But nowadays, machine learning is more popular. But for machine learning, actually, especially if we talk about AI or deep learning, Well, actually, machine learning can include the traditional, algorithm for data classification or regression. Okay, and it also includes the neural network or even deep learning. But in this community, usually whenever we talk about machine learning, we restrict it to the traditional algorithm. Okay, and for the neural network based or transformer or any deep learning model, that will be another. We will separate it, but actually could be machine learning is one of the overall could be AI, and AI could be include the machine learning, and machine learning could include deep learning, and so that. Okay, so the main focus of this semester is before the midterm exam. Okay, before the midterm exam, I will focus on the traditional algorithm, which you might use a lot for your research or for your project. Okay, such as SVM, support vector machine. Okay, and random forest, for example, we use a lot. Okay. But after the midterm, we will shift to deep learning model. Okay, the deep learning model. Okay, so that's my plan. Okay, before that, let me. After class, you can download all the class material, okay, from the portal, okay? I don't assign any textbook, and which means you don't need to buy any textbook, okay? All the material, you can find it from the portal, okay? So the first part, for example, about machine learning, where we the traditional, okay, algorithm. So you can download the DP means data pattern. Okay, so it will include supervised and unsupervised learning. Okay. So please download the machine learning supervised part 1 and part 2. Okay, you will include 2 parts, and then unsupervised. Okay, and unsupervised. When I say supervised, I mean you only have the input X. Okay. For example, it's n-dimensional. You have the feature as well, could be the height, could be the weight, could be the ages, okay, or education level, and etc. Okay, and then you will have so the data has the form. You got xi. Now let me put sk. And the corresponding output, expected value, okay, or level. That's called supervised. So when you train your model, you need to collect a set of training data that include the input features, okay, and also this could be the class level, or it could be some regression value. You want to do it for forecast. Okay, this is so-called supervised, okay, supervised learning. And the so-called unsupervised learning, which means the data set, you only have the input, that's it. Okay? So most of the application is by using clustering. 那个分群 you only have X, and you don't know what should be the corresponding Y. Okay, used a lot for data mining. Okay, you want to separate the customer into different groups so that you can have a different promotion strategy. Okay， 那个用在电商很多了。什么样子的顾客来？那这些顾客有什么偏好？你的行销策略是什么？等等的。Okay，so that's the main difference: supervised and unsupervised learning. Okay, so you can download the corresponding material. Okay, from supervised part 1 and supervised part 2. And then I will talk about the unsupervised classes. So you know I need to do all this in 2 months. Okay, so it's almost mission impossible. But before that, okay, starting from next week, you need to download this material. I will talk about this first, PCA and ICA. As for dimension reduction, okay? For example, you collect a feature vectors that contains dimensional features, then we would like to do some pre-processing, okay? So PCA and ICA, you can think of this as a pre-processing for any data analysis, okay? PCA means principal component analysis, and I will go further to talk about independent component analysis. Okay, take it as a pre-processing. Just for the topic might take me 2 weeks. I don't know. Let me go back to the data, okay, that I'm going to talk about, okay, or the algorithm you are going to use, okay, for handle different application. The data can be first, of course, can be a vector value, okay? Can be a vector value, just like the one I showed you here, okay? This is a vector, right? It's a vector. It contains n components. Okay, the first one, let me say the example again, could mean the weight, the height, okay, and the education level, and Y for focus could be what? Could be is annual salary, okay? So let's go vector value, okay? And well, actually, I should divide it into this called structure. Let's call it structured data. Okay, structure is well structured. You've got all the features. But the problem with the structured data is the user need to define or find or to design the features. Okay, and you need to select the right features for your application. Go back. Should I include the height? Should I include the weight? Should I include the ages? Should I include his education level? And etc. etc. Okay, so that will be the user's responsibility to collect all the variable features, and then you will select the most important one. Okay, for your further classification or regression test. The other data type is called unstructured. Okay, unstructured data. It will involve a class, image. Okay, could be image or even video. This so-called the unstructured data. The other one, I won't say anything about image because I have already talked about the application for image in machine vision class. So I won't say anything about it. My focus in this semester, especially for deep learning, will be time series, okay? time series data, such as manufacturing process signal, okay? Or for some vital signs signal, such as heartbeat. Okay, you can monitor the heartbeat of a patient, so you can see is there any anomaly. Okay, or for manufacturing, you can identify something wrong with the machine or with the process. So that will be the focus. Okay, that will be the focus. But when I give the example, okay, for each algorithm, I might use image as the example because the result is much easy to visualize. Whenever I talk about the time series, maybe you have no idea what's going on here. Okay, so but let's just give you the visual for visualization. But the main focus is not for image or video application. Instead, I will focus on time series data, especially for deep learning. Okay, especially for deep learning technique. Okay, that will be the main focus. Okay, because some of you have taken my machine vision course last year, okay, last semester. So for the deep learning part, you will see some redundancy, but that should be okay because the focus on time series data could be a little bit different. Okay, even you use for deep learning, unstructured is unstructured data. It doesn't matter because for image is you can think of image as a two-dimensional data. Video is a three-dimensional data, and time series data basically is a one-dimensional data. That's it. Okay. For deep learning, basically they are the same. Okay. There's no difference. But in real application, there's a little bit different for the implementation. But anyway, even you will see some redundancy here, but it should be okay. Okay, it should be okay. You can learn something new. Okay, especially for time series classification or for time series focus, and for short-term and long-term focus. So it should be no problem with it. Okay. Anyway, starting from next week. Okay. Make sure you will download the material. Okay, you can bring your own top lab, okay? Or if you want to print out, I will recommend you just print it single-sided, so you can use the other side to write the note. Okay. The way I prepare the class note is so-called cell content. What does it mean? I select not to use the PPT slides because when you read the slide, you will miss a lot of the details. But the way I prepare the material is the cell content, which means if you cannot understand what I'm talking about during the lecture, when you go back home, and you can get all the details. Okay, you can get the details from the class note. That's my purpose. But the font size could be too small. Okay, so make sure you will download it, okay, to your laptop or print it out. Okay, and bring to the class, and so that you can take note. Okay. So anyway, starting from next week, okay, I will talk about the PCA and ICA, okay, for dimension reduction, okay. For this case, originally we have n dimension, then how to reduce it to 2 or 3, okay, or less. Okay, I'll give it more detail. Anyway, PCA is nothing but a pre-processing for ICA. Okay, usually when you apply, I mean independent. Okay, it will separate whenever. Actually, throughout this semester, when we talk about the traditional machine learning, actually we talk about projection, nothing, just projection. 投影，我们只讲投影，事实上只有投影，只有投影这件事情 ，just projection. Then you want to projection to what direction for PCA? You will project to the direction that will show you the maximum variance. That's it. For ICUA, you will project to the direction so that all the project components are independent. Okay, independent statistically. Okay. Then we will talk about what does it mean by independency and uncorrelatedness. Okay. 不相干不等同独立哦。这是 uncorrelatedness of two variables is only the necessary condition for independence. And why is that important? Then we are getting to that. Okay, starting next week. And I also will give you the example by image. Okay, I will give you, because in the early day when people use face recognition, they do apply PCA and ICA for face recognition. You can use for, and I will show you how to do it. Of course, nowadays everybody uses it differently for face recognition, no. But it's still a very important pre-processing technique. Okay, we're starting from here. And then we will go for the supervised. And, okay, well, actually, this is the traditional way. And for part 2, I will talk about ensemble. Okay, I will talk about ensemble learning. Ensemble, which means you make the decision not rely on one classify. You will rely on a set of different classify and how to apply it. Even the baseline or best classify is a neural network. How to use it. Okay, then. And after that, we will go for the unsupervised classing that will include the traditional, okay, classing way. And I also will talk about how to apply the deep learning, okay, how to apply the deep learning for unsupervised classing, 分清, So that will be. Okay, so anyway, let me show you what is the material will look like. Okay. That's what I'm saying. I mean, the font size could be too small, but my intention is you can learn it, okay, after class. Here's something I would like to show you, okay? That's the basic algorithm. First, you need to do a lot of data cleaning, statistical analysis, and PCA, ICA, and blah, blah, blah. And after that, the algorithm can be divided. And then, as I mentioned here, especially you are handling the feature base or vector value data, you need to do some feature selection, feature extraction, or feature design, especially for the unstructured data, okay? For unstructured data. If you go for the structured data, basically when you face the vector value data, you don't need a very complicated neural network. All you need is just MLP, okay, multi-layer perceptron. That'll be good enough. So the more complicated, even for transformer or convolutional neural network, is used to handle the so-called unstructured data because it does not present with the vector or with the features. Okay. Anyway, and then you need to do some feature design, feature extraction, feature selection, and then you can apply it for classification. Okay, or for regression. That's the two main purpose of data pattern recognition. Okay, two applications. One to classify the input should be class 1 or class 2, okay? In manufacturing, this could be what to classify the defect type so that you can have a better control of the process, okay? Or you can identify different types of customer, okay? So that you can have develop your own marketing strategy, okay? So the other very important application is for regression, okay? That were the two main purpose, okay, for this class, okay. So one for classification, the other one for regression is the main objective, okay. Now let's back to the classification. The method can be divided, as I just mentioned here. It can be supervised, okay, which means you have the input data set and you need to provide the corresponding response, okay. For classification, Y could mean the level 1, level 2, okay. But for regression, it could be a value, okay, such as the stock price. You can base on what the historical data, then you can focus, or it could be the stock price tomorrow or next week or even the next month, okay? Or Y could be the temperature based on what you have, or based on what you have, then you can estimate what could be the sales, okay? So that's for classification or for regression, okay? So for supervise, we will start with Bayesian theory, okay? 也就是我们开始先从贝氏几率从贝氏几率谈起 ，OK， Bayesian theory，what is Bayesian theory? Anyone? The most simple equation is what? Given B, you assume you know something about B. Then you want to know the probability of the outcome that you will get A, right? It's a conditional probability given B, which means something you do know, okay? Then based on what you know, you want to estimate the probability for B. And you can write down as right? The difference here is what? You know something about A. Then you want to know what could be the outcome, what could be the probability for B, right? And times what? A. Divided by B. Right, very good. Very good. Yeah, that's what you have learned from the statistics, right? So what is the purpose? Why you need to? It's not used to pass the exam, right? But what is the purpose for the Bayesian theory? I mean, what is the difference? You know something about B, then you want to estimate the probability for A. And what is the difference between this one and this one? It's very important for machine learning because this is not trainable. You know what I'm saying? You can collect, or it's almost impossible to collect the sufficient data to train the model. It is not trainable, but this is much easier to train. I will talk about that, but just keep it in mind. That's something you need to learn, okay? Not just to. So anyway, for machine learning, you need to have some basic knowledge. But if you don't, not be fine, okay? Not be fine, okay? I will explain that later on. Okay, but anyway, we will start from the Bayesian theory. And so it means what? If I only have an X, that could be the height, okay? Then you want to estimate with an object you measure the height, it's 170 centimeters. So what you will be a male or female? For a adult male or female? Now, if I put it 190, this could be much easier for you to make the decision, right? If it's 190, then you would say definitely. You could be wrong, right? You will. So in this case, the probability, okay, given you know the length, the height is 190, then you will assign this object as a male. Will have the probability larger than a female, right? So we can base off. So from here you will know if we want to do this, you need to do what? How to train or how to design the distribution with this and this. It's very difficult. You know what I'm saying? Because you need to measure all the possible height. Now, it's too difficult. But
using the train.
that's what I'm saying. This basically is not trainable. This is much easier to train because you need to collect what? All the male objects. For example, you want to know the height for the student in YuanZe University. So you need to collect, right? You get to measure the height of male object or male students. It's much easier. And then you can find the distribution, right? This could be male and this could be female. And then that's the reason why we need to use Bayesian theory, because the original one is very difficult. Or it will cost you a lot to collect a sufficient number so that you can estimate the probability. But with this one, you just collect the male object and also what? The female object. So you know something, right, about the object that you collect, right? Then you can compare the difference. That would be easy. That's why you need to learn the Bayesian theory, okay, especially for machine learning. Then what should be the probability? Then that will be the topic we talk about, okay? Anyway, especially for some of you have learned the machine vision. If you have no idea about the probability, about the distribution, what will be the good choice for that? Anyone? You have no idea at all. Because we are going to use it throughout the whole semester. If you have no idea, it could be uniform, it could be a gamma distribution, it could be blah, blah, blah. So if you have no idea, the best assumption is what? You will follow normal distribution, let's say Gaussian distribution. That's all you need, okay? And you will see that again and again for all the machine learning algorithms. And you fix, okay? And you fix because most of the time, because central limit theory tell you if the observed data is the combination of another different independent variable, then the observed mixed data always will follow Gaussian distribution. So even for you measure the vibration of the machine, the vibration of the machine, that is your observation, but the observation could come from what? The machine error, okay, or even the temperature, or the humidity, and something. Anyway, everything combined with a lot of different independent variable, the outcome usually will follow Gaussian distribution. So when you have no idea at all, just take my word, the Gaussian, okay, just go for Gaussian. It may not be true every time, but most of the time, since you have no choice, right? You have no better idea. Just go for the Gaussian, and you will see that. Okay, and I will show you how to estimate the probability when we talk about the Bayesian. Okay. Okay, so then the other way, if we don't go for the probability, okay, especially the Bayesian theory, then the other way around is so-called discriminant analysis. Okay, discriminant analysis. For the discriminant analysis, suppose we have a two feature, okay? Suppose we have a two feature, x1, x2, okay? x1 could be the height, x2 could be the weight, for example. And you collect a set of data point, okay? For example, okay? Each represent one data point, okay? Represent one data point. And then you will collect, suppose we go for the supervised learning, okay? We go for the supervised learning. Then for this case, you will find a decision function, okay? You find a decision function. Okay? So, if you observe an unknown data point, suppose this could be male. Let me just make the assumption, female. This is x2, this is x1. Okay, then the question is what should be, okay, this object that belongs to male or female is based on this decision function. So the decision function simply so. Okay, we input the height and the weight. Okay, so if the value, if this function value is larger than 0, then you will say that belongs to the male class. That's the so-called discriminant analysis. Okay, you need to then obviously SVM is one of the standard model. It could be, but the model could be, as I mentioned here, the discriminant. Let me go back to Bayesian. The Bayesian could be parametric approach and non-parametric approach. The so-called parametric approach is, as I just mentioned, if you have no idea about the distribution, you simply assume it's Gaussian distribution. That's it. But for a Gaussian distribution, at least you need two variables, right? You need to determine what should be the optimal variable, okay, to fit the probability. So for that case, you need to determine what should be the mean value and the variance. Okay, that's so-called the parametric approach. For parametric approach, usually you need some optimization algorithm. Okay, when I say optimization, which means it will take time, especially you want to online real-time classification or regression, it may not be a good choice. The other way around is so-called non-parametric approach, which means you don't need to make any assumption about the distribution, okay? You don't need to determine what should be the probability. It does not have to be a Gaussian distribution. It can be, you don't need any assumption. So since you don't need, assume you will follow Gaussian or any statistical distribution, which means we don't need to determine the parameters. Okay, that's so-called non-parametric. I believe some of you have used this a lot, such as what? K-nearest neighbor, K-nearest neighbor. And also I will introduce kernel base, okay, based on kernel. Okay, I will introduce, what does it mean by kernel? if I collect a data, for example, okay, I have a 10 data. Now I'm going to ask what could be the probability of 7 based on the data you collect. What will be the probability? 0, right? Because we cannot see any value outcome of 7. But if I say okay, X could be mean 1, 2, okay? If the difference is less than or equal to 1, then what would be the probability of P7? Now, this won't fit. No, it is okay, right? 6, because the difference between 6 and 7 is 1. Not this one, not this one, not this one, but it's okay. So the probability will be what? 0.2. So the generalized equation for that so it means the unknown X and the training, if the difference is less than or equal to 1, H is so-called bandwidth. Bandwidth, for this case, the bandwidth is what? There must be less than 1, right? Right? If I divide it by 2, it's less than 1, then what will be the probability? Which means this should be less than 2. Then this will fit, right? 9 will fit. And also 5 will fit. So the probability will be 0.4. You know what I'm saying? Here's a parameter called bandwidth. You can manipulate a lot. Anyway, this can be a function. Okay? This can be a function. This so-called kernel density. Okay? They're very useful. It don't need to make any assumption. Okay? It does not have to follow any distribution. You just need to define what should be the kernel function, so-called kernel. I will define what does it mean by kernel. And here's a parameter. So anyway, throughout the semester, there's no way you can understand every topic, okay, I present to you. But the only thing I ask is you need to know the terminology at this, the terminology. You will know the terminology. So that what? When you need to use the machine learning or deep learning for your work or for your research, you will know what to ask to ChatGPT or Gemini. You know what I'm saying? Otherwise, there's no way you can ask. If you ask the wrong question or you assign the wrong prompts, you will get the wrong answer. So if you cannot understand every single algorithm I talk about, that could be fine with me, but at this, my purpose, okay, throughout this semester, I will introduce as many terminology to you as possible. And the other thing you need to keep in mind, what could be the limitation of each algorithm. So you won't misuse the wrong algorithm for your application. Okay? So 我唯一的目的，第一个哈，因为我相信不可能在短时间能够知道我在讲的每一个主题啊，因为里面很多都数学，可是你至少它的名词一定要记住，还要知道它的限制。The the other thing is when you even use the tool, okay, you can download another, no matter it's free or you need to pay for it. It will ask you to input the hyperparameter. When I say hyper, I mean the value must be determined by the user, and you need to know what it asks. For example, the edge is the bandwidth. Then you need to, what? What should be the input? Should be 1 or 0.1 or 100? Then depends on your application. Even nowadays, there's an auto ML, okay? The so-called, it will determine the hyperparameter or even the architecture for you automatically, but it may not still be the best way for your application, because for when you implement your machine learning algorithm, you need to consider what the training time, the inference time, the number of data set. Okay, you know what I'm saying? You got to know what is the limitation and what should be the hyperparameter you need to provide. You need to know what the system is asking. Okay. For example, you ask input the bandwidth. Whoops. If this is something to do with the Gaussian, when you ask the bandwidth, actually it means what you're asking the variance or standard deviation. But bandwidth could be a more general term. Okay, so that's something you need to know. Okay, even you cannot understand every single step, every single mathematical equation. So, but try to remember all the terminology that you can use. Okay, so for the basic, we'll go for parametric and non-parametric. And for discriminant, then it can be linear or it can be non-linear. Okay, we should take a break, right? I didn't hear that. Okay, anyway, let's let me see. Okay, it's wow. Okay, let's take a break. Okay, I will finish all the topic in this semester. Okay.